Do you believe that by simply stepping onto a train in Beijing, just 5 hours later, you could find yourself in Shanghai, 746 miles away, faster than it would take you to go through airport security and board a commercial flight? This is not science fiction. It's a reality that China is bringing to life with its ultra-high-speed Maglev train. In a groundbreaking trial in Shanxi province in 2024, China's Maglev train reached an astonishing speed of 621 m, far surpassing the typical commercial airliner speed, which ranges from 547 to 575 m. This achievement marks a new era for global transportation where distance is no longer a barrier. This accomplishment is not just a remarkable number. It's also a testament to China's ambition to lead the transportation revolution. While other countries, including the EU, are still grappling with outdated railway, China has made a bold investment in Maglev technology with projects like T-Flight promising to revolutionize the way we travel, connect, and grow. But how did China achieve this breakthrough? What is the vision and plan behind this achievement? In just 2 decades, China has written an astonishing story of transformation in the field of high-speed transportation, turning a backward railway system into one of the most modern networks in the world. As of 2020, China boasts over 27,960 miles of high-speed rail, accounting for 2/3 of the total global high-speed rail network. This figure not only reflects the massive scale, but also highlights the unprecedented speed of the country's development. From Beijing to Shanghai, from Guangzhou to Chengdu, hundreds of cities, large and small, are connected by modern trains that shorten travel times and boost economic growth. In just 15 years, China has built a transportation system that many countries would take centuries to achieve. In contrast, the United States still finds itself in the early stages of high-speed rail development. The EU currently has just 456 miles of high-speed rail, primarily the Amtrak Acela line running along the East Coast with a maximum speed of 150 mph. Meanwhile, China's CR400 Fuxing train, dubbed the Revival, reaches speeds of 217, offering superior comfort and efficiency. This gap is not just in technology but also in strategic vision. China has invested $550 billion in transportation infrastructure from 2016 to 25. A sum that far exceeds the $120 billion budget allocated by the EU for railway projects under the Infrastructure Act of 2021. This strong investment has enabled China to build not only railways but also an integrated network connecting economic hubs and remote areas. A significant milestone in this journey came in 2004 when China inaugurated the Shanghai Maglev line, the world's first commercial Maglev train covering 18.6 miles at a speed of 268 brand. This marked a turning point, propelling China to the forefront of high-speed transportation technology. The line was not just a technical achievement but a symbol of China's ambition to reshape the way the world moves. Since then, China has continued to expand its aspirations, investing in the research and development of ultra-high-speed projects like T-Flight with the goal of ushering transportation into a new era. It is this perseverance and long-term vision that has allowed China to outpace other nations, including the EU, in the race to build modern transportation infrastructure. These accomplishments have not only changed the way people travel, but they also laid the foundation for a future where speed and efficiency become the standard. Maglev technology. Maglev train or magnetic levitation trains are not just a mode of transportation. They are a testament to the intersection of science, engineering, and human ambition. Unlike traditional trains that roll on track, Maglev trains use powerful magnetic fields to levitate a few inches above the tracks, eliminating all mechanical friction. When combined with low vacuum tube technology, which reduces air resistance to a minimum, Maglev trains can reach an astounding speed of 6,219, faster than conventional commercial airliners, which typically fly at speeds between 547–575 mph. This technology is not just an engineering breakthrough, but a statement that China is leading the global transportation revolution. At the heart of Maglev technology is the high-temperature superconducting HT system. This system uses superconducting magnets to generate strong magnetic fields, allowing the train to levitate stably without physical contact with the tracks. The result is a smooth operation with almost no vibrations or noise, providing an exceptional experience for passengers. More importantly, the HTS technology helped save up to 20% in energy costs compared to traditional high-speed trains, making Maglev not only fast, but also efficient. A Maglev train can accelerate from 0 to 404 mph in just 7 seconds and decelerate safely in less than 656 feet, a feat that other transportation modes can hardly match. The ability to operate stably at such extreme speeds opens up possibilities for long-distance routes where travel time can be significantly reduced when placed in an international context. China's superiority in Maglev technology becomes even more apparent in the U.S. The Hyperloop concept proposed by Elon Musk once gained attention with a goal of reaching 280 mph. However, the project was cancelled in 2023 due to high construction costs and a lack of government support. Meanwhile, China continues to invest in research and development. With laboratories like Donghu and Hue pushing the limits of Maglev technology, innovations like the ability to operate in low-vacuum environments combined with advanced control systems have helped Maglev trains become a symbol of China's innovation. This technology not only overcomes technical barriers but also lays the foundation for ambitious projects promising to turn high-speed transportation from a scientific idea into a practical reality. These advancements have strengthened China's leadership position while other countries are still struggling to catch T-Flight up. The T-Flight project led by the China Aerospace Science and Industry Corporation (CASIC) is not just a technical breakthrough but also a bold statement of China's ambition to shape the future of global transportation. In a historic trial in Shanxi province in 2024, the TFLY train reached an incredible speed of 623 over a 124-mile track, officially breaking the previous world record set by Japan's L0 SCM Maglev train which reached 602 mph. This achievement has placed China ahead of Japan. Once considered the pioneer in Maglev technology and laid the foundation for an unprecedented era of ultra-high transportation. What makes T-Flight particularly special is not just its speed but also the groundbreaking technologies integrated into the project. First, the artificial intelligence AI-driven navigation system allows the train to maintain an impressive positioning accuracy of just formula motor, ensuring absolute safety even at extreme speed. This system continuously analyzes data from thousands of sensors, predicting and addressing any risk in real time. Secondly, T-Flight utilizes vacuum tubes made from advanced composite materials which are lighter and more durable than traditional steel, reducing infrastructure construction cost by 30% while withstanding low-pressure environments. Additionally, the integrated renewable energy system, including solar-powered batteries and energy regeneration mechanisms from braking forces, boost energy efficiency by 15% compared to conventional mag trains. Remarkably, the real-time sensor system monitors over 1 own miles and data points every second from track temperature to train vibrations, ensuring stable and safe operations. The T-Flight project is not stopping with these initial trials. China is constructing a 37mm test track at the Donghu laboratory in Hue province, expected to be completed by the end of 2025. This track will allow the train to reach speeds of up to 621 mm in a real-world environment, paving the way for commercial applications. When compared to other nations, T-Flight's superiority becomes even more evident. Japan, while developing the Tokyo-Nagoya Maglev line with a maximum speed of 314 mph, is not expected to complete it until 2027, much slower than China's speed in progress. Meanwhile, the United States currently has no similar Maglev projects. With efforts like the Hyperloop being cancelled in 2023, T-Flight is not just a technological achievement, but a testament to China's ability to turn bold ideas into reality, laying the groundwork for a future of ultra-high transportation. Impacts. China's ultra-high Maglev train is not just a technological leap. It promises profound changes in economic, social, and environmental aspects. Economically, the Maglev system can drastically shorten travel times between mega-cities such as from Beijing to Shanghai, a distance of 746 miles, reducing travel time from 5 hours by high-speed train to just 1 5-hour. Compared to airplanes which take about 2 5 hours including airport procedures, the Maglev saves nearly an hour. This speed not only provides convenience but also boosts trade and tourism, with forecasts predicting an additional 2% contribution to China's GDP by 2030. Key economic regions from the Pearl River Delta to the Yangtze River Delta will benefit from tighter connections, creating millions of job opportunities and regional economic growth. Socially, the Maglev system has the potential to alleviate pressure on China's crowded airports. Beijing International Airport currently handles over 100 million passengers annually and often faces congestion. By diverting a portion of passengers to Maglev, major cities will reduce congestion, improve travel experiences, and enhance urban residents' quality of life. Maglev lines connecting satellite cities to economic centers will also foster more balanced development, enabling underdeveloped areas to access better economic opportunities environmentally. The Maglev train offers significant advantages over traditional transport with emissions of only 0.08 CO2 per mile per passenger. Maglev is more than 60% environmentally friendly compared to airplanes which emit 0.2 kilo on CO2 per mile per passenger. This aligns with China's commitment to carbon neutrality by 60, making Maglev a crucial component of its green transportation strategy. When compared to the EU, where road and air transport accounted for 29% of total greenhouse gas emissions in 2023, China is demonstrating a more sustainable approach. While the EU still relies on slower rail lines such as the Los Angeles-San Francisco Road, which takes up to 3 hours for 380 miles, China is building a transportation system that is not only faster, but also contributes to the protection of the planet. These impacts are not only changing the way people travel, but also setting a new standard for modern transportation. With China leading the way in combining speed, efficiency, and environmental responsibility. Future. China's ultra-high-speed Maglev train is not only a technological breakthrough, but also the foundation for an ambitious vision of the future of global transportation. Over the next decade, China aims to build a Maglev network spanning more than 100-mile connecting megacities like Beijing, Shanghai, and Guangzhou by 2035. These routes will not only shorten travel times, but also create an integrated transportation system, driving economic and social development across the country. For example, the journey from Beijing to Shanghai, which is already fast at 5 hours by Mag, will become the standard for other intercity routes, creating an unprecedentedly efficient transportation network. However, China's ambitions do not stop at its national borders. With the T-Flight project, the China Aerospace Science and Industry Corporation (CUSIC) is aiming for a bold goal. Reaching speeds of 485 miles per hour, directly competing with supersonic aircraft. This speed, 4 times faster than current commercial jets, could make intercontinental travel a reality. Imagine a future where passengers can travel from Beijing to London, a distance of over 5,000 m in just 8 hours compared to the current 11-12 hours by plane. This vision is not just science fiction but a goal that Chinese engineers are working towards through advanced experiments in laboratories like Donghu and Hube. Furthermore, China is looking even further ahead with plans to export Maglev technology to regions like Southeast Asia and Europe. Countries such as Indonesia and Thailand, with an increasing demand for high-speed transportation, are potential markets for this technology. In Europe, where current high-speed rail lines top out at around 186 mph, China's Maglev could reshape how major cities like Paris, Berlin, and London connect with each other. The Maglev export market is projected to reach a value of 100 billion in the next 2 decades, offering not only economic benefits, but also reinforcing China's position as a leader in green transportation. With low emissions and high energy efficiency, Maglev could become a sustainable solution for countries seeking to reduce the environmental impact of transportation. When compared to the United States, the difference in vision becomes clear. The EU currently allocates only 0% of its transportation budget to high-speed technologies like Maglev. While China is 10 to 15 years ahead in this field, low-speed rail lines like the Los Angeles-San Francisco route with a 3-hour travel time for 380 m are hard to compete with compared to the efficiency of China's Maglev. However, China's leadership is not just a challenge, but a call for other countries, including the UN, to invest more heavily in future technologies. If Maglev becomes the standard for intercontinental transportation by 2050, as China is aiming for, the world could witness a revolution in how people travel, connect, and develop. China is not just building trains, but shaping a super-fast future where distance is no longer a barrier. China has made history with the T-Flight project and Maglev technology propelling high-speed transportation to unprecedented levels with a record-breaking speed of 623 mph. Innovations such as AI-powered navigation, composite vacuum tubes and integrated renewable energy. China has not only surpassed Japan but also left other nations including the EU far behind in the race for transportation technology. These accomplishments are not just about speed. They stand as proof of China's strategic vision, persistent investment, and commitment to building a more sustainable future.